I've lived on the bottom of York Peninsula for my entire life, run a caravan park down at Corny Point and work as an aquatics instructor as well. And we've been watching the bloom since the start of April, starting down on York Peninsula well before kind of the metro coast started to be affected. The beach I grew up snorkeling and swimming at, we had the entire ecosystem wash in over the course of a week. We found 150 sea dragons in a day across a couple of kilometres. Yeah, just heartbreaking. Waves of kind of this real deep depression of just knowing that all of this ocean around us that we're so used to calling home is just suffering.
I reckon it was about 2 weeks after the initial reports came in that we're starting to think about different ways to actually record what the impacts were. So I've been a long time user of iNaturalist, so it's a global citizen science platform, so people upload their photos along with the date and time, and that provides a whole bunch of public, usable biodiversity information. The Marine Mortality Project was set up with the idea to try and document what was dead. So what that project does is it automatically collates any marine records that are based in South Australia where it's been recorded as a dead animal. That way we could figure out where the dead stuff was versus the alive stuff. It has its limitations because it means we get stuff that's outside the algal bloom, but it's done a really incredible job with just documenting the broad diversity of species which are impacted.
Very early in the piece I was recording everything we were seeing, posting on social media, and luckily very early in the piece I'd been in touch with the marine scientist and he'd directed me to where the project was. Pretty quickly we amassed a pretty large number of observations of what was going on.
So the great thing about citizen science is anyone can do it. So the real benefits and power of using the iNaturalist platform has been that there's over 1,000 people who have contributed to the project, which means that we're getting photos from across the state, from a variety of different regions, at different stages of the algal bloom as well.
I've lived in Port Noarlunga for about 25 years. Art has been part of my life, environment has been part of my life, and so the beach has also been a big part. Then all the algal bloom popped up and it was like, I kind of need to document it. I was really bad at it at first, and now I've got much better at it. I've really just sort of lumped all fish as fish. But no, there's just amazing differences. When you're snorkeling, you see the stingrays and the other fish around you, that's okay, but to see them on the beach and just in such incredible detail. So yeah, there's both heartbreak and sort of curiosity too. So I try to ignore like the total numbers of things, but it also makes me feel like I'm trying to help the situation. Sort of giving some of the control back, I guess control is the right sort of word, control to just help out and even just contribute the data for future use.
It was kind of the one thing that kept us sane. We felt like we could do, of everything that was going on, we could do one thing, which is just kind of show other people what was going on and make sure that data was with the scientists.
Having that public data set means it's going to be used for all sorts of things it already has. So the Mortalities project itself has already been used for informing researchers to go collect specimens of rays, having the public collect reef fish that normally we'd never be able to get to do ultralith studies.
The iNaturalist site has been incredible, like such a wealth of information for scientists like myself who work for government agencies or universities, and we don't have the people power or the resources to go out and do those surveys. So for the community to be able to collect and log that amount of information is just incredible. I saw things on iNaturalist and also on the news as well, and then when I went and did my first beach visit, I saw these little warty prowfish, which is a tiny little fish, a cryptic fish, which I've probably only ever seen about 2 in my whole life diving, and in that first visit I picked up 8 of them off the beach. And that's when I sort of got the idea that, you know, we could be using this to collect some of these species and learn something about them. Cryptic just means it's really hard to find. So they're often a lot of these are quite well camouflaged, and they're quite small. They don't move around much as well. So it makes them really hard to find, especially for people like me that are getting a bit older when you're diving. I'm now working with Professor Bronwyn Gillanders from Adelaide University here and her lab, and we'll get them processed. We can do some work with the otoliths, with the ageing of them, find out about their reproductive biology, just all sorts of things that we don't know, because most of these species we don't know anything about them.
There's 3 sets of air bones in the heads of fish, and the largest ones are ones that we would typically use, and we take a cross section of them and you can count growth increments in them. So it's a bit like taking the cross section of a tree, and you know how you can see the growth increments in the tree? You can do the same with fish air bones. So that means that you can use them to age them, and then you can also measure the width of the growth increments and relate that to environmental conditions. So when it's really good environment, you'll get wide growth increments, and when it's not so good environment, you'll get narrower growth increments. So we can build what's termed growth chronologies and back through time. So if we know when we caught the fish and we estimate the age going backwards, we can estimate back, say, 50, 100 years, what the conditions were like that the fish experienced.
Then we can find out, you know, things about their life history, how long they live, when they reproduce, and that's going to be really important for the recovery of these species, because what we know from something like the blue devil, we've done some ageing on those previously, they live to 60 years of age, and they're really site attached, so which means they live in the one location for most of their life. So yeah, we've got real grave concerns for the blue devil populations off the Metro Coast now. They have these unique markings on their face, and that way we can identify individual fish. We can also give them names like Hollywood, which is my favourite fish. It's hard not to get attached to these fish, especially the ones like Hollywood, which, you know, is quite inquisitive and comes up right in your face when you're diving, and you know, you're kind of having this interaction with it. And to think they've been living, you know, on the reef for so many years, you know, 10, 20, 30 years probably, most of these fish. And then, yeah, they're all just washing up on the beach. So yeah, it is very sad and quite emotional. Observations logged on iNaturalist, it has GPS information with it, so the location, and so yeah, that's going to be really important to know where on the coastline those fish were washed up, especially if we do any genetics work.
We'll also take tissue samples, so that can be used for genetics, and that can help identify whether we've got a range of species. But if we get samples from different areas as well, then we can start looking at how their populations are structured, likelihood of connectivity between populations, and that can help determine whether stocks are likely to rebuild or not.
If we're having all these fish wash up dead, which would otherwise just sit there and decay or be taken away by the beach cleaners, but now we're going to actually learn something about those species, which I see as a positive, because otherwise we just wouldn't go out and harvest, you know, 50 anglerfish or 50 warty prowfish. It'd be hard enough finding them for a start. We just wouldn't do that for science. So now we've got this opportunity, so I see that as a real positive. From talking to people on the beach when I've been down there, and just the people I've met through iNaturalist, it's just opened their eyes up to the diversity of marine life that we have out there. I suppose we've got to take that as a bit of a positive spin as well, that you know, people don't sort of understand what's below the surface out there, and yeah, it's just a special environment we've got here. Yeah, we need to protect it and look after it. So I think that's a great thing that's come out of this.
The single scientist couldn't go out and document what's been documented, like, and over as broader spatial scale as they've citizen scientists have done it. But when you've got like multiple people in the community that are all interested in all helping, it helps document what's been happening.
I think it's just a credit to Janine and Brad for getting this started and having the vision to get it going, because it's just invaluable.
What's really important to recognise is that project, it really has the ownership by the community. So there's no one organisation that has any ownership over that project. It's public, it's there, and people are welcome to use it for all sorts of different types of studies and analysis, as it should be, being public and transparent data. So it's shown the power of citizen science and what that recording means. But also the long-term benefits of that database will mean more restoration, more rehabilitation, and trying to understand what species are most impacted.